All right, so today we're going to talk about something called relations. And in my opinion, this is just my opinion, I think this is the single most important topic that we will cover in algebra this year. So this is it today. This might sound kind of weird, especially after we do it, because it's a kind of a weird topic, but I think like fairly simple, not that complex to understand. But this really lays at the heart of algebra and how algebra works and why we do algebra. So, relations. That's our topic for today. So, there's a table over here on the right. If you look at this, and there's a question here. It says, "What's the relationship between the number on the left and the number on the right?" And so, relations. What we're talking about today just has to do with relationships between numbers, and it's not like relationship like boyfriend girlfriend, but if you look at the table here and you look at the numbers on the left and then you look at the numbers on the right, there's a pretty clear relationship between the number on the left and the number on the right. And if you look at it for a minute, you'll probably notice it. So I actually want you to look at that table and see if you can figure out kind of a pattern or relationship. Pattern's a good word also to describe what we're doing today. So I would say, I didn't give you a whole lot of time to think there. I would say that the number on the right is double the number on the left, right? 2 is double 1. 4 is twice as much as 2. 6 is twice as much as 3. So on and so forth, all the way down. So let's write that. So what is the relationship between the number on the left and the number on the right? The number on the right is double the number on the left. So that's the relationship. Number on the right is twice the number on the left. Double the number on the left. Okay? All right. So whenever, I'm just reading the notes here, whenever two groups of numbers, inputs and outputs, have a clear relationship between them, we pair them up with each other and we call the collection of those pairs a relation. So what we've done here is we've actually shown this is called a relation because it's showing you how the inputs, usually we put the inputs over here on the left, are related to the outputs. So we call that a relation because they are related. 1 maps with 2, 2 matches with 4, 3 matches with 6, so on and so forth. And what's interesting here is that we actually have several ways of showing the relationship between inputs and outputs. The same relation is shown in 5 different ways. So I took actually the same pattern or the same rule, right? What was the rule here? Double the number on the left and you'll get the number on the right. I took the same rule here and wrote it out in 5 different displays. So there's 5 different ways to show a relation. The first way is a table right here. So you're going to have the inputs usually on the left and the outputs on the right. So that's one way to show it. There's a mapping over here. So what you do is see how -2 matches with 3. What we're going to do is we're going to take -2 and 3 and draw a line between them over here on the mapping. Okay, and then let's actually finish the rest of them. So 0 pairs up with -1, so 0 goes to -1, and some people will actually draw arrows here. 1 matches with 0, so if you have an input of 1, the output is 0. If you have an input of 2, the output is 3, so 2 goes to 3. And then 3 goes to 8. So let's go 3 to 8 there. Okay? So this is called a mapping. It's basically the same thing as a table, although on the table you'll notice that notice how there are only 4 output numbers here, even though there were 5 here. That's because 3 appeared twice, and you had -2 going to 3 and +2 going to 3, and you can see that. See how they both go to 3 there. So it's slightly different, but basically the same idea. Another way you can show a relation is ordered pairs. So we have ordered pairs down here. So you have, typically what you do is you put the input value, which we usually refer to as x, and then the output value goes next to it. So when you plot points like -2, 3, you know how you go -2, so left 2, and then you go up 3 to plot a point? That's what these are right here. Those are called ordered pairs. So that's yet another way to showcase the relationship between the inputs and outputs. Okay, so Okay, so those are called ordered pairs. We don't need to write anything for those because they're already done for us. The next way that you have to show a relation is called symbolic or function notation. Symbolic just means symbols, right? Symbol. And then function notation is, that's just kind of the name we give for it. So what we're saying here is we're saying, hey, the output, which is the y's, is the input times itself. So it's x squared. It's a number times itself, and then you subtract 1. So that's what it's saying here. Which is funny because some people find like the table to be very helpful in understanding the relationship, and some people really like the symbolic or the function notation. They say, wow, that's actually a lot easier for me to wrap my mind around the relationship when I see it written like this. So it just kind of depends on the person. Okay, the last way of showing a relationship is a graph. So what we've got down here is an XY coordinate plane, right? This is the x-axis, this is the y-axis, and then what you do is you plot the points. So let's take these ordered pairs here and draw them. Okay, so -2, 3 is the first one. I'm going to color code these. So -2, 3 is the first one. -2, 3 is going to go right there. The next point is 0, -1. So 0 for x, -1 for y. So we're going to come down here. 0, -1. Next point is 1, 0. So 1 for x, 0 for y. Let's see, the next point is 2, 3. So 2, 3. And then the next point is 3, 8. So 3, 8. So what's interesting is if you continue to draw more and more and more points on this relation, it actually starts to kind of look like this U-shaped curve, like this. It's actually symmetrical, which is kind of cool. So this is really interesting. So depending on how you look at it, you might look at it like this with symbols. You might look at the graph to figure out how this relation works, like the kind of the pattern between the numbers. Some people really like the table. This helps them visualize the relationship. It just depends from person to person. Okay? All right. Here's a question. What is the relationship between the inputs and the outputs of this relation? So I would say this. I would say the output is the input multiplied by itself then subtract 1. So the output is the input multiplied by itself, then subtract 1. And really that kind of came from the symbolic notation there. I think that's the easiest way to see it. It's kind of hard to figure out exactly what the rule is by looking at like tables and ordered pairs and graphs like this. I think the symbolic notation like that is really helpful to kind of visualize or understand the relationship between the inputs and outputs. All right, let's flip over to the back page here. So what they want you to do here is they want you to explain what identify the type of display on the left, and then they want you to recreate it on the right. Okay, so what kind of display is this right here with these guys? Those are called ordered pairs. So we're going to say that's ordered pairs. And then they want us to create a mapping. So here comes our mapping. You ready? We're going to put the inputs here, the x's, and then we're going to put the outputs here, the y values. So the inputs, if you just look at the inputs over here in yellow, we've got 2, 1, 4, 7. 2, 1, 4, 7. You don't even have to write them in order. Some people do, but not like super essential. And then you got 3, 5, 6, 2. So then you have 3, 5, 6, 2. So 2 maps with 3, 1 maps with 5, 4 maps with 6, and 7 maps with 2. So that just comes over pretty nicely. Not super complicated there. Okay, so that's it for that one. So we took ordered pairs and we mapped them over, or we mapped them over to a mapping. Yeah, I mean that's basically what we did. We turned it into a mapping there. Okay, all right. What kind of display is this? This is called a graph. So when you visually draw the relationship between the x's and the y's, then that's called a graph. Okay, so now we're going to make a table. So let's actually write these out. So this blue point right here is at 1 for x and 2 for y. So the x-coordinate's 1, the y-coordinate's 2. How about this orange point here? I would say that's when x is 2 and y is 3. How about this red point here? That's going to be when x is 3, y is 4. And then the purple point here is when x is 4 and y is 5. So that's taking a graph and kind of translating it into a table using the same information. Okay? Y equals 2x plus 1. What kind of display is that? That's called symbolic, or you could say it's called function notation. And they want us to create ordered pairs. So basically what we're going to do here is we're going to say, look, if the input value is 3, so in other words, if the x is a 3 there, what's the output value? So we're going to have to do a little bit of arithmetic here, a little bit of math. So if you plug in a 3 there where the x is, what would you get for the y value? You would get 2 times 3 plus 1, so that would give you 7. So if x is 3, y would be 7. Now let's kind of ask ourselves, what if x was 2? Now, so if you do 2 times 2 plus 1, what do you get? You get 5. Right, so if you plug a 2 in where the x is, you get a 5 for the y. What if you plug in a negative 4 for the x? So if you do 2 times negative 4 plus 1, that would give you negative 8 plus 1. That would give you negative 7. And then if you do, this one's backwards. So this one's saying the output value is 9. So we're saying when we do 2x plus 1, we get 9 for the y value. Now we're trying to work backwards to find the x value. So this one's kind of backwards. What would you have to do there? So I guess we could solve, right? We could minus 1 on both sides. 2x equals 8. So x must be 4, right? If 2x is 8, then x must be 4. Okay, so we took a symbolic notation here and kind of translated it over into its ordered pairs there. Okay, what kind of display is this? This is called a mapping. So this thing's called a mapping, and what it's done here is it's taken the x values and shown you what y values they map to. And now we're going to graph it. So let's look at this point that I'm now highlighting in orange here. So this is a point right here. It's saying when x is 0, y is 5. So when x is 0, y is 5. Let's put that point on there. When x is 0, y is 5. So that's that orange point right there that I just put on. Let's do this right here. So this is 1, 4. So we're going to do a red point when x is 1, y is 4. Let's do a blue point now. Negative 2, 7. So negative 2, 7 would be this point right here. And I'm running out of colors here. 4, 1. Let's do that in purple. So 4, 1 is going to be in purple. And then, I don't know if I have any more unique colors here. Did I do yellow? Yeah, okay. 6, 1 is going to be our last point there. It's kind of hard to see. I probably shouldn't have picked yellow. I'm going to draw it black there. Can you guys see that right there? Yeah. Okay. So this would be a mapping, and then this would be the graph that would match it, basically. Okay? All right. What kind of display is this? This is called a table. And remember, they're all on the front page, right? If you go back and look at your front page, they're all right here. Okay, so you guys have that to refer to. Okay, so this is called a table. And now we're going to graph it. So if the x value is 4, let's use good colors here. If the x value is 4, the y value is 1. So when x is 4, y is 1. So I come over to 4 for x, and then I go up to 1 for y. How about this right here, 0, negative 1. So 0 for x, negative 1 for y. And then next one is 2 for x, 0 for y. So 2 for x, 0 for y. And then the last one here is negative 2 for x, negative 2 for y. So negative 2 for x, negative 2 for y. Okay? And what's cool about these is you'll notice on some of these relations, like on this one, you could actually draw a line through those points. So a lot of times you're going to run into tables and, you're going to have stuff like y equals 1/2 x minus 1. And if you actually check it, right, against the line, like they all match. So that's what we're going to be talking about over the next few weeks.